This video will demonstrate how rehash and load factor work with the unordered set. Hello, I'm James Helfrich. The unordered set is unique because it reallocates and resizes itself for the purpose of maximum performance. It does this by rehashing and by modifying its size based on its load factor. This video will demonstrate how both of those work. We'll start with three related concepts. The first is size. Like most containers, size method returns a number of elements currently in the unordered set. Notice how size returns a size t, which is an unsigned integer. Now, the unsorted set utilizes a hash table as the underlying data structure. This consists of a number of buckets, each of which can have 0 or more elements. We can determine the number of buckets in the hash table with the bucket count method. Notice this also returns a size t. Finally, the client can specify the number of buckets in the underlying hash table. This does not change the number of elements in the unordered set, but may cause the collection to be rehashed. This means a new table containing size buckets is created, and every element is inserted in the new hash table. We use the hash method to accomplish this task. To demonstrate how this works, we'll create an unordered set of integers that has 4 buckets. We're also going to set our maximum load factor at 2.0. We'll figure out what that means in just a minute. So when I execute this code, I'm going to have 4 empty buckets in my unordered set. Now I'm going to insert the value 31. I'm using a default hash function, so the hash value of 31 is 31. 31 mod 4, because there's 4 buckets, puts it in bucket 3. Then I'll insert 49, which is going to go in bucket 1, 11, which will go in bucket 3 also, 28, which will go in bucket 0, and finally 67. Now 67 mod 4, because there's 4 buckets, is also 3, and that's going to go in bucket 3. Now, when I say rehash 8, I'm going to create 8 empty buckets. Now, I'm going to iterate through the old unordered set, and I'm going to put 28 in the new one and 49 in the new table. Notice 49 mod 8 this time gives me 1. And then 31 mod 8 is 7. And then 11 mod 8 is 3, and 67 mod 8 is also 3. And now when I'm finished allocating the new hash table, then I'll get rid of the old one and move the new one over. And that's how rehash works. The unordered set's hash table will rehash when the number of elements exceeds the number of buckets. The ratio of elements to buckets is called the load factor. We can determine the load factor of the unordered set with the load factor method. Now, by default, the unordered set will rehash when the load factor is going to rise above 1.0. This is called the maximum load factor. And we can determine where the maximum load factor is currently set in the unordered set with the max load factor method. And finally, we can also adjust the maximum load factor. Most research has shown when the max load factor is 0.7 to 0.6, that's the optimal spot for an unordered set. That's the good balance between having the smallest number of collisions and the smallest number of unutilized buckets. For some reason, the standard template library sets its maximum load factor to 1.0. If you would like to adjust that to any other value, you can call the maximum load factor as well. Notice this version takes a parameter, and that's the setter, where the version of the maximum load factor without a parameter is a getter. To demonstrate how this works, we're going to create an unordered set of integers with 4 buckets. I'm going to set the maximum load factor to 1.0. So when I execute this code, I'm going to have 4 empty buckets, and initially my load factor is 0.0, because that's the ratio of size, which is 0, to number of buckets, which is 4. 0 divided by 4 is 0. Now I'm going to insert 12. Now, since I'm using the default hash for integers, 12 is going to be the hash value. 12 mod 4 is 0, so that's going to go into bucket 0. And after I insert 12, then my load factor is going to go up to 0.25. And why is that? Because there's one element divided by 4 buckets, and that's 0.25. Now I'm going to insert 50. 50 mod 4 is 2, and my load factor goes to 0.5. 38 mod 4 is 2, and now my load factor goes to 0.75. And 67 mod 4 is 3, and my load factor goes to 1. Now, I'm not going to rehash yet because I'm not yet exceeded my maximum load factor, which is 1.0. However, when I try to insert 93, this is going to push me over the top. So that's going to cause me to rehash. So I'm going to create a new hash table that has 8 empty elements, and then I'm going to iterate through the old hash table. 12 goes into the new table. Notice how 12 mod 8 is 4, where 12 mod 4 was 0, so it goes into a different bucket. And then 50 goes into bucket 2, 38 goes into bucket 6, and 67 goes into bucket 3. Now I'll insert 93. Oh, when I'm finished with that, now my load factor is going to be 0.5. Now I'll insert 93, and 93 goes in bucket 5, and my load factor goes to 0.625. And then I'll insert 55, and 55 goes into bucket 7, and now my load factor goes to 0.75. You can learn more about the hash, the load factor, the maximum load factor, rehashing, and many other things in the hash chapter of the C++ data structures textbook.